Here we have a permanent magnet, and we can see we have a south pole and a north pole. If I bring a compass near it, the compass is affected by the magnet. Okay, we can see that the needle moves around. Now the red part of the needle is the north pole of the compass. Right? If I move it around to here, I could start at this side, and you can see that the compass needle is pointing directly away from the magnet. If I bring it over, right, I can see that the compass needle is pointing towards the corner, or away from the corner, I apologize. And if I bring it slowly over, you can see the compass needle turn until when we're in the middle of the magnet, it's pointing roughly parallel to the magnet, right? So when I'm over here, it's pointing essentially parallel. And then I bring it this way, and it starts pointing back towards the corner. But this time, the north is pointing towards the corner and not away. If I bring it around here, the north points straight to the left. If I bring it back to the corner, it points towards the corner. And then I keep on bringing it around, and the compass needle sort of flips. And now it's pointing parallel again. Okay? And we can keep on going with this as many times as we wanted. You can see the pattern in the compass needle pointing away from the corners here, and then away from the north pole here, and so forth. Okay? There it is, parallel again. And towards the corner. Okay? And so you should be able to fill out your sheet with the compass needles and the circles based on this data. Okay. Here we have an electromagnet that is not particularly magnetic. And the reason it's not particularly magnetic is there's no actual electricity flowing through it. The electricity is going along this green wire through the electromagnet, right, to the white wire, right, goes here to a light bulb and then stops. So we haven't completed our circuit. Our circuit is broken. And if I clip this to it, right, the light bulb turns on, and we can see now electricity is flowing through the circuit. So we have what's called current flowing through the green wire, through our electromagnet, along the white wire, through the light bulb, right, and back to the battery. And so we have a complete circuit, and we have moving charge going through our coil. We can take our compass and we can put it near our magnet, our electromagnet, and we can see that the needle points towards it. If we, there we go. And if we bring it to the corner, you can see that the compass needle turns, right? And if we follow it, we get to where it's the middle of the magnet and it's pointing parallel. And then we can bring it over here towards this corner, right? And it starts pointing towards the corner again. Right? Oops, there we go. If I bring it to the end, you can see that the compass needle points directly away from the magnet, right? Points directly away from it. And if I bring it further, now it points away from the corner, right? If I bring it over, you can see that it's starting to point away from the magnet. But if I bring it to the middle again, it's back to being parallel. Okay? If I bring it over farther, it starts turning. And then when I bring it back to the corner, it's pointing in towards the corner. And if I bring it around, it points back directly towards the magnet. Okay? And we can repeat as much as we want. So we can see that it's a magnet because the compass points towards it. It moves the compass needle, right? And in fact, we can see that, right, we can see that the needle points parallel to it here, right, or here, right, oops, right, or over here. So there we go. And so we get that same parallel compass needle. Okay, great. When you're doing this lab activity, we had the permanent magnet on the table, and if you recall, we had south on the right, and so we would put an S for south over there so that we know what part of the magnet we're talking about. North was on the left, and so we want to label the two ends. So you labeled the two ends of your magnet here. Now you didn't have a magnet on your piece of paper, but you would be drawing the arrow that was on that compass, and one end of the needle was colored, and it was the north end of the needle. And if you recall, on the when we were at the south pole of the permanent magnet, the compass needle pointed straight towards it. Now I can just draw an arrow in this direction and show the magnetic field. If I wanted to get really creative, I could draw an actual compass needle arrow, but this is just great. So we'll just draw a straight line to the left, and there is our first data point, right? So you can then go around, if you watch the video, go around and label the other arrows, and you should see a pattern. Okay. And remember, you're really looking for when it was at the corners of the compass, right? Right at the end of the compass, right at the middle of the compass, right? And then somewhere in between the corner and the middle. Okay. That's pretty much it. Then you're going to answer questions. Don't forget to label the two parts of this based on your data above. Okay. There's no blank written right here, but you should probably answer this question as well. Right. Now, when you get to this part of it, you have our electromagnet. We have the electromagnet, and if we were to look at the video, I believe again we would see that the needle pointed this way at this end of the electromagnet. And again, you can go around the electromagnet and draw the compass needles in on your diagram. Okay. Then lastly, answer the questions. So the one thing that's going to be important here is that we're really talking about what we're putting through this wire is current. It's moving charge. Okay. And the name for moving charge is current. Okay. So we're putting current through this wire in this loop, right? And we're getting a magnetic field. And so you should be able to answer the questions. This is just asking how the two fields that you drew in the lab are the same or different. In this one, looking back at stuff that we did first semester, you should know which part of the Earth contains the metal that you would need to make a permanent magnet, right? Because our Earth has a magnetic field. Compasses measure that. Which part of the Earth actually has a metal that could be magnetized? Right. And then lastly, just picture what would happen to our magnetic field here if instead of having the current going through the wire in this direction, we had the current going through the wire in the opposite direction if we just switched the leads of the battery. And that is it.